A buddy of mine is tuning up a 2010 STI, and he's done full bolt-ons. He's got the cob access port, so really pushed the kind of stock system as far as it can go. Got some reasonable power gains. It's a hell of a lot sportier. Sounds nice. Got a recirc valve on there, dumping full air, making whoosh noises. So it's come a long way to date, but he wants to take it to the next step. And we want to preserve all the expense and time and labor that's been put into his bolt-on. So we're looking to do something custom turbo inside OEM housings, get as much as we can out of that. So what I've prepared for him here, we got nearly everything ported, coated. We got a custom turbine that we'll review here. And this is going to be a multi-part build because there's a lot involved. I got all new housings, center, front, and rear, all aftermarket. And we're also going to put on the vf48 Mamba turbo, the kind of bolt-on specific wastegate, do electronic boost control on it as well, or at least upgrade the stock electronic boost control to like a 3-port Mac valve. I think he's using Grim speed. So if you're looking to do this turbo repair, RHF55 kit is what you're looking for. We got upgraded bearings for this one. So purchase both a standard replacement kit. Like you'll notice I've got multiple thrust collar and spacers and other parts. It's because I'm working with two kits here, standard and upgrade. We'll take a look at the upgrade bearings. And we'll slap this thing together. I'm thinking today we're going to focus on center housing and turbine wheel. So first step, I'm going to take this guy and get some ceramic coat on it. But it's been deeply ported out, at least 10 millimeters, like a full centimeter extra diameter at the inlet. These inlets on a stock turbo are totally insufficient. You'll also notice that there will be a carbon ring of buildup as that exhaust flows directly into like a major ridge, right where you need that flow to spin the turbine wheel. So porting on the exhaust housing is imperative for this, in my opinion. It's probably a major bottleneck on the stock system. I've also ported out the outlet of the turbo as well as inlet, and not quite knife edge, but basically, that silicone coupler is going to pinch in slightly. So just nice transition from coupler into inlet of the turbo, and then compressed air out into coupler. And as far as custom turbine here, went with again, I talk about Borg-Warner a lot. I love the compressor side of Borg-Warner, so we went with a Borg-Warner clone 7+7. It's got extended tips on the compressor wheel. It's got that same kind of 65% height on the secondary blade versus major versus minor. So it still affords for a nice big air channel, high RPM flow, but it's definitely going to move that, compressor map into the low pressure ratio zone, which is typical of Borg-Warner, like S200, S300. They flow real well at low turbine speed. They flow great at high turbine speed. So big fan of Borg-Warner compressor wheels. And I've been trying to mirror that technology in all the custom stuff. And then on the turbine side, just went with a classic like Garrett GTX style 9-blade. And I don't have another vf48 like stock turbine to show you. I'll show you the one I picked up used. I was going to try to get some measurements off of it, use it as a comparative, and really I wanted to get the housings. Like I prefer to work off OEM housings, but the one I picked up was destroyed, so we'll go take a look at that. But let's get started assembling this center housing. Was hoping to build off like an OEM Subaru turbo, get some usable parts, but the one I picked up was not usable. Almost everything about it was destroyed, so we got like obviously cracking, things chipped off on the center cartridge. Previous owner probably tried to hammer it apart or something. The wheels are completely destroyed. Like there's like multiple millimeters of missing material. Of course, the front housing was also completely chewed up. Short of trying to like CNC the housing to fit a bigger wheel, which is outside of my pay grade at my home garage. Not much usable. The turbine may be usable, but I think I paid $30 for the whole turbo on Facebook Marketplace, and I'll be using almost nothing off of it, and that's fine. I'm willing to make investments into science. But I guess a couple things to note. Note that overhang on the center nut, like the turbine shaft nut to the compressor wheel. So we've got a little ridge right here. You're definitely not getting airflow through solid metal. Also, no extended tip, but the base of the wheel fits within that backing plate smoothly. And then on the turbine side, you've got a typical, I think, 11 blade, and check out the width of the nut relative to the fins. That nut and that shaft is taking up a lot of space. They do that for strength. That material weighs a lot. And primarily that's because they're using like a cheap alloy that needs the extra mass for, thermal conduction and strength while it's real hot. So I don't know. Unfortunately, I don't think this is worth the money for bearings to rebuild, even if I could put new wheels in it. So it's probably going in the trash. All right, the first step in this rebuild is the hardest part. So with your rebuild kit, or if you buy a brand new housing, you're going to find that the center bore is just empty. And I've already done this part off camera because it's a little finicky, takes some time. But essentially, you're going to take this guy. You'll notice it's got a hole in the bottom. You're going to line that hole up so that the oil will come out the drain. Absolutely imperative. Once it's driven in, it's going to be very hard to orient this. So do it right the first time. But dunk it in your assembly lube. You're going to put it in the hole. Often I'll freeze these. This one I just drove in both parts at room temperature. If you freeze this, it'll shrink it slightly, make it a little easier. But you're going to get a driver of some kind, and my favorite is to use a tapered punch that's going to stop at the ID of this bushing, but is not so wide that it's going to touch the inner diameter of your bearing bore, which is essential. You do not want to scratch this. But essentially, you're going to drive it in until your bearing fits below this surface on the front side as a good check. You also have to check the back side. Typically, you're going to have more space on the back than the front. You want to be a perfectionist. The way to do that is to drive it in until your oil orifice, so this guy coming into the bearing, a little bit hard to show, but you reach in with a 90-degree pick and you feel, so for instance, right there, I'm touching the side of the bore. Once you get your oil passages aligned, it'll slip in significantly more. So that's what I've done here. We've got alignment of the bearing oiling holes with the oil hole in this guy. And then this is the surface of the thrust washer, a tiny like 0.5 millimeter gap below that lip. So yeah, very important that this bearing is not tight on the thrust washer. That would cause a major problem. You'd probably self-destruct on your first startup. So be aware of those things. So I'm just going to give a little final check off camera here. Make sure this is all lined up, and then we'll throw some bearings in. So I've used my bearing now to check clearance with that kind of spacer or collar bushing in. And our next step here, a little hard to see, but as that collar is driving in, it will transfer a bit of like streaky material down the bore. I drove this front to back. So there's some streaks of that bushing material in here. I want to get those out. So what I'm going to do, just apply a little assembly lube on that bore. And then we're going to use a soft tone brush to wipe it away. So this isn't going to grind that inner bore surface, the bearing bore surface, but it'll just sweep it a little bit. And it's a good opportunity because it will kind of change the surface texture. Like it's probably like an 800 grit, but we're going to sweep it quickly and try to induce like a little bit of a crosshatch for oil retention. So not much to it. Just line it up. So very hard to show, but we do have that kind of crosshatch effect now. And just checking, got a nice gleaming surface, no more material transfer. So it doesn't take a ton. And we'll do the exact same on the rear. So there wasn't any streaks on this side because the bushing entered from the opposite side. But just to be absolutely sure that there's no burrs in there. And of course, there's a little bit of dusting and stuff left from the brush, so I'm going to go blow this out with brake clean and then high pressure air, make sure it's totally clean, and we'll drop bearings in. Got this guy all cleaned out. And now just a simple quick dunk in assembly lube. Being pretty generous with it. And I'm going to lower it in with a pick. Can be a little tricky, you got to get it in very much straight up and down without scoring it. Just gently nudge it into place. So easy enough. And the rear retainer on these is just a little like kind of push retainer clip. Apologize, my camera's having a bit of focus issues here today. But essentially prongs facing backwards. Again, just dropping that in there. Using your pick to orient it as straight as you can. And now I've just got, this is a 9mm socket, but something to just firmly press down on that clip with. It won't take a lot of force. That bearing's done. And then as a final check, we're just going to try to spin that bearing, make sure that it's free. And I'm just being very careful not to scratch anything here. So bearing moves without any resistance. And that's going to confirm that our collar spacing is correct as well on the back side. Next bearing. And applying that extra lubricant to the thrust washer area here. So the thrust washer has been in the freezer. Get it a little cool. And then we're going to quickly install it with the bevel facing down here. And it takes a little bit to line it up correctly. It's got to go totally straight in. And important here not to drive it with anything. You don't want to mar up this brass surface. So just making sure that guy is nice and tight, and the beveled side of that washer is facing down for oil drain. I'm going to argue that it's probably not that important. I've taken a lot of these apart, like OEM ones, and found the bevel like up here. Ultimately, this inside diameter, that washer is not touching your turbine shaft at all. I mean, if it is, you've got a play issue with your bearings. But, you know, best practice, might as well follow. So we've got the flat side of that washer facing down here. So this thrust washer is sitting a little bit high still. I could press it in a reasonable amount with my fingers, but obviously not all the way, so it's necessary to drive it. Not an uncommon problem to have. The reason they're so tight is because they don't want this inner diameter of the washer like floating and touching your turbine shaft. So what I've done here, taken Teflon sheet that I've got, and I'm just cutting out a little circle that's going to fit right on top of our thrust washer there. And taking a 12 mil socket as a driver and high density rubber hammer, I'm just going to lightly tap that thing the rest of the way home. Just keeping everything square. Yeah, I saw it move. So it looks pretty good. This side is a little high, so we'll give it another little bump. It doesn't take a ton of force, but we're just doing everything we can to not mar up that thrust washer. It's going to kind of offset the driver to the one side. Checking clearances, it's still slightly high on that side. Got to get this thing in there totally square. All right, we've now got a nice consistent clearance with the bearing. And like before, I'm just going to reach in there. Bearing's moving nice. And it's got a tiny bit of lateral play too. So now we're good to go with the actual thrust bearing and then inserting the turbine. We got our thrust washer fully seated. Everything's ready to go. So next step is going to be this kind of little thrust spacer, and then our actual thrust bearing. And then on top of that, this will be installed in the front kind of sealing plate, and it's got its piston ring on it. You simply kind of push those rings, inserting the closed non-gap side, and then the gap spreads. You just simply push it on, very easy. We'll oil that and install it in the front plate shortly. But it's worth noting, with this assembly, the custom turbine we've done here, not only is there markings for balance on the wheels and the nut, shaft, etc., it was also balanced with the thrust spacer and this front collar. So we're going to do our best here. I've made a mark on the oil drain. We're going to do our best to line all that up. Now, this isn't going to matter that much because these parts are very low mass. They're kind of held together by the clamping force of the bolt, but they don't necessarily touch that turbine shaft. Typically, these will not be balanced with your overall assembly. So we've just gone with a really fine high-speed balance here. So here's our mark on the thrust spacer. So let's go ahead and drop it in. Touch of assembly lube. And looking at this thing, there's a beveled side. Beveled side faces down, probably just for aiding in oil flow across that face. I'm doubtful that it matters. There's a little bit of clearance there. Then we've got our upgraded thrust bearing. So noting just some deeper machining on all the oil passages for flow. It's also got an actual groove across the face for oiling instead of a single hole. So it'll be better cooled, better oiled under high load. And we're just going to line up this guy with our oiling orifice and our drain with the drain section. The bolts will not allow you to orient it any other way. With a touch of oil on the internal diameter here. Again, shouldn't be in contact with the actual turbine shaft, but for assembly. We've got these tiny little T10 Torx bolts to hold it in place. I insert them with no thread lock. Many guys will thread lock them. I don't love having thread lock inside the turbine housing. And also, they're really just there to prevent this from shifting in the event that it's touched by the turbine shaft, but it shouldn't ever be touching. So it's just orientation bolts. They're very fine. I want to say like a metric 4 mil, maybe less, maybe like an M3. So just hand tight, like snugly hand tight. It'd be very easy to strip these things out or pull them or stretch them. So I'm just going to do like a quarter turn, an affirmative quarter turn on each guy. Double checking to be sure. So from here, going to grab a little bit of brake clean, and I'm also going to air out the bolt holes. Just make sure all this is clean, but we've got an assembled center section. All of our bearings are done now. Mindful that this is sitting below that surface. Everything looks good. I'm just taking a look at that orientation mark. I do need to just make a slight adjustment here. And this is the reason I've made that mark where it is, so that you're able to see that through oil drain. All right, good to go. Got our thrust collar with piston ring installed, and I've added balance mark aligning with the other balance marks. So what we're going to do, just throw it in the assembly lube, and we're going to install it into our front sealing plate, kind of the compressor wheel backing plate. So just using a tool to dunk. And this is a lot more assembly lube than is probably required. But we want to be sure that it really gets behind that ring. So the ring actually expands and holds itself on the front plate, and the collar spins within it. So the lubrication really needs to be in the groove, and less so on the outside, but full dunk should be sufficient. And as a best practice, I like to keep the gap in the oil groove up top. Making sure we got that groove oriented properly. Doesn't have to be perfect. And sometimes you can lose the tip of a glove doing this. There we go. We've got this thing Cerakoted on the back and the front, so we're really adding a lot of thermal protection to the overall assembly. Wasn't fully seated there. And testing that it spins freely. We've seen in previous videos that occasionally you'll get like a burr or something and it'll hang up, but it spins real nice. So without dropping oil on it, just a little bit more on the back there. We've already done this, but absolute certainty. Now what we're going to do, and you'll often see when these are assembled, so I've got the cast iron portion all cleaned off, degreased. I'm going to add a little bit of silicone on the inside of this guy and then bolt them together. You'll often see OEMs, other turbos, there'll be no sealant there. It's definitely a common place for kind of a little bit of leaking or sweating. So we're just going to use a little bit of silicone to defeat that problem. And you don't need a lot. But what is important is that you are going to silicone the outside, but also around the interior portion of the bolt hole. You don't want oil like sweating up through your bolt into the inside of your compressor cover, and then you'll think you've got a blown piston ring, when in fact it's just the lack of silicone. So just doing one more sweep here to make sure it's nice and clean. And as long as I've preserved that balance mark, I'll be able to orient the collar when we go to put in the wheels. So Just got to rip out a little wad of dried silicone from my tube here. And I'm actually going to deglove for this, just for the precision. So just an absolute little smear. And I like to use a slow drying silicone for this kind of thing, so you got time to work. And just enough to stick these guys together. You don't want it gushing on the inside of the housing. So there's going to be a couple places here where it's difficult to reach with the fingertip. And what we'll do is apply the silicone to the center cartridge side in those areas. So just as best we can. And then on the cartridge side, a little smear right along there. And on the outside of the bowl holes. I'll just smear any excess around. All right. So I'm going to quickly clean my finger off so I'm not getting any silicone on our beautiful coated pieces. But it should drop right on. So I've put a tiny bit of Loctite on the bolts. There's a bit of silicone smearing into those bolts too. Just get them started. I'm being real gentle here because I don't want to drop my tool on the coating. It's pretty robust though, like a drop tool or dropping the piece usually doesn't screw anything up too bad. I'll go over and give these guys a final kind of tight hand torquing, if you will. But the only thing left to do here is locate our oil drain right about there, and then hard to see, but we've got our balance mark right there. So I'm just going to orient that guy toward the oil drain. Just like we did with the other internal parts. And the reason I did it before doing this is there's a high chance I'm going to wipe that alignment mark off. Well, it looks like it's going to survive. There you go. So just want to stop the clip, one last final tightening, and we are ready for heat shield on the back and wheels. Piston ring installed on the turbine here. So again, same type of thing. The ring expands and holds onto the housing. Turbine rotates inside the ring, so it's really the groove that we're most interested in lubricating. Just get a healthy dose inside the groove. Spin it around a couple times. Little smear on the bevel it's going to pop into in the seat. I like to wipe up any excess just because you don't want to have like smoking on first start. From here, heat shield simply placed. Bunch of lube on the turbine shaft. And slowly inserting it in case anything became unaligned. Yeah, so my collar is a little off or something. There we go. It won't take a ton of force, but just a little downward pressure with the rotation, it'll typically pop in. There we go. It's barely noticeable, but it's fully seated now. And then holding your heat shield up or keeping it vertical, just so this doesn't drag on it. There we go. Nice smooth operation. Again, just feeling for burrs and stuff inside. It's kind of your final check. So we got our balance marks here lined up with the oil drain. And now we're just gonna throw the compressor wheel on in its kind of rough orientation. Because once this is sitting on that collar, it'll start moving the collar. So here, before moving the collar and while I'm gripping, it's gripped on the bottom here. Just gonna get everything into alignment right there. Looks good. Using a fingertip, just the smallest smear of Loctite. just a tiny little bit. So I bumped my compressor wheel there, but it's now resting on that pedestal, so they are in alignment. Just bringing that back into alignment. And with the flange side down, right hand thread. I even started it the wrong way there. And you'll notice it'll always come to a stop just beside its final destination. So really what's important is to align shaft and wheel. And now we're ready to final tighten this shaft nut. It's going to be a little difficult to show this, but essentially I've got shaft mark here, wheel mark almost with the shaft mark, but it's going to get budged slightly, and then nut is further out of sync. So as we give that shaft nut its final bump, it should shift everything into place. And there is a torque spec for this, but I do not go off torque specs. The orientation is the only thing that matters. And it's always just a hand tight process. There we go. Took almost nothing on this guy. It's a very small, like an M6, I want to say. Very small shaft thread. So just got to support that rear heat shield so it doesn't drag. And we've got total success here. There's a little bit of the thick assembly lube inside is kind of holding it up, but she's spinning beautifully. Little sneak peek of what it'll look like. I've just got the compressor housing placed on it. But there you go. 7+7 front side inside a ported OEM housing. It spins beautiful. You can kind of take a look at the alignment marks there maybe. But we got everything really nicely aligned. So that is an entire Subaru vf48 center housing complete. You can see nice tall wheel, extended tips, give me an extra couple millimeters of pumping surface area. This is going to be its final home for now, so I've just got it resting off the wheels. If you like that video, let me know. If you got questions, let me know. Really enjoy making this stuff. I'm really enjoying making this turbo specifically. It's going on a buddy's car, and there will be dyno results, and hopefully we can compare it to a stock setup, stock turbo, or maybe the tuner may have some maps with like stock plus bolt on to compare it to, so that'd be awesome. But I'll follow up with a part 2 when I get the rest of the housings all ceramiced up, and then we'll make sure that the housing clearances are good. There's a little bit of an issue with clocking. This guy's got a pin to clock on the back, so that's good, no guesswork. Front side, no orientation mark or anything. So we'll get it bolted together. A little skim of silicone up here for certainty, and this thing will be ready to rock. So like and subscribe. See you next time.